All right, so page 49, lesson 7. Again, all, some, or no solutions. Which one doesn't belong for the equations and why? Brenna?
Ooh, 3 because there's a 2.
3 because there's a 2. Somebody other than 3.
4 because it's wrong.
4 because it's the only one that's wrong. That's false. Jonas?
2 because it's the only one that has multiplication.
Only one that has multiplying.
1 because it's the only one who's adding.
Perfect. Again, you can make a case for any of them. You need to explain why. Okay? Now, keep in mind when you were doing equations, guys, if you were to graph them, I talked to you about this before class, 3 things can happen. They would be parallel, which means there is no solution. Those lines would never cross. What's going to be a hint that that would happen if you look at the equation?
Same on both sides.
Same what?
Number.
Same value.
Same value. Yeah.
How, same slope. Okay? So these would have the same slope.
Oh.
That would determine if they're parallel. Okay, so keep that in mind when we look at the equations. Other thing that could happen is they could intersect. That would give you one solution. This would be no solution. They would never cross. This would be one solution. That means they cross in one spot, no matter if they're perpendicular or super different slopes. It don't matter. They will cross at one spot. What are you looking at?
Like they're crossing
One solution. I just abbreviated solution. Okay, and how do you get all solutions? That means you graph the exact same line. They would be exactly on top of each other. That means everything works. They connect on all the spots. Infinity solutions, all solutions. Everything works, however you want to say that. All right, so we're going to look at that with equations today. Just keep in mind, if you're to graph them, that's what we'd be looking for. Question number 1, sort these into 2 types, true for all values and true for no values. Okay, so let's sort a couple of them. True for all values. That means they'd have to be the same on each side of the equation. Do you see any that are the same?
The first one.
Obviously, the first one is the same, so I'll circle the ones that are all. I'll show that by circling the word all in this one. Other equations that are the same. Georgia.
The third one.
Which one? What do you mean by third? Down or across?
3n plus 1 equals 3m plus 1.
All right, let me ask you this, Georgia.
What?
If I were to take 3 times n, what would I get?
3n.
If I were to take 3 times 1, what would I get?
3. Oh my god. Sorry.
So that one does not work. That is not the same.
Okay.
Josh.
2t plus 6 equals 2t plus 3.
Yes, that one is. If you were to distribute that, it'd be the same. Just to give you a hint, I have 1, 2, 3, 4. 4 of them that are the same.
The bottom one of the first one.
This one?
Yeah.
1/4 of 20d would be 5d. 1/4 of 4 would be 1, so we need a plus 1 there yet to be exact. So that one does not work. Georgia, trying again?
Yes. I'm going to go with y times -6 times -3 equals...
Yeah, -6 times -3 is 18. 2 times 9 is...
18.
So yes, that one works. There is one more. Josh.
5 minus 9 plus 3x equals -10 plus 6 plus 3x.
That is correct. That would be 3x minus 4 on both sides. Okay, so some of them were not very simplified, which made it a little more confusing. So those are the ones for all. Now, no values. Remember what that means with our line. They will not cross. That means the slopes are the same.
The g2 equals g minus 2.
Yeah, so you see all the slopes there would be the same. They both have 1v. But are they the exact same line?
No.
No. So the other 4 are no values. They're all the same. Now be careful. Some people will say, well, these both say 3x. That means they're parallel. But remember, they're the exact same line. Both of them would simplify to the exact same thing. Okay, so you can't just look at the slope. You have to look at the whole line. Question number 2. Write the other side of this equation so it is true. So why don't you try it? You write something on the right side of the equation that is the exact same as the left. Okay, and don't just write the exact same thing, please. If it was me, I would distribute and simplify it, and then that's what I would write down. Evan?
50.
How'd you get 50? Okay, can I ask you how you got that?
I distributed
Okay, so 6 times u is,
60.
6 times negative 2 is,
-12.
okay, and I still have the plus 2. So what can you combine then when you have 6u minus 12 plus 2?
12 and 12 and 2.
But it's negative 12 and positive 2.
You can add 12 to each side.
Negative 12 plus 2, I'm not even looking at the other side yet. That's negative 10. So I'm leaving it as 6u minus 10. I'm not doing anything else. Okay, so that would be the same on both sides. I just simplified the left side. Now it's the exact same equation on each side. Remember, that's what it means for true for all values. Same equation. Okay, number 3. Now find one that works for nothing.
Like find a bowl.
So it's going to be parallel.
What?
If you were to graph it, they would be parallel. They would never cross. Sure. Only thing that matters is this. You could have 6u, because that's what means it's parallel. Same number in front of the variable. Slope is the same. You could have 6u plus 1. You could have 6u plus 2. You could have 6u plus 3.
But the 0 doesn't work.
You could have 6u plus 0.
No. I originally put 0.
You could have 6u minus something. As long as it's not a minus 10. You can have anything you want after it. Or nothing. Only thing that mattered is it had to have the same slope. That means it's parallel. Y-intercept won't change that it's parallel. All right, question number 3. We're going to skip the are you ready here. It says complete each equation so that all the values are true. Why don't you try ABC there? You want them to be true. That means they have to be the exact same on both sides. Anybody confident on the first one?
Yeah.
Brody?
2.
2. Any other number you could put there?
No.
No, 2 is the only possibility. Remember, 3x, 3 times 2 would give you 6. B, a little trickier. Gotta be careful with the negative signs. What would I put there? So if I would distribute that negative sign, I would end up with this. Sophia?
2.
2 again,
4.
because the negative would make it -2. Very good. Next one. Brenna.
3x.
3x. Because 15x divided by 5 is 3x. -10 divided by 5 is -2. Exactly right. Okay, switching to the next part. Find one that works for no values. Give you a minute or two to fill that one out. So again, no values, slopes are the same. Doesn't matter after that. Colin.
1.
Perfect. Anything but 2.
So 8 works?
Sure.
Oh, so
Put 2.
wait. I'm.
You can put anything you want right here besides 2, you'd be right. Actually, that's not true. If you put an X, it would be wrong, because that would change the slope.
Dang it.
Any number there, you'd be right. Georgia, what'd you write?
Don't ask.
Did you put a letter?
I bet you put a 2. I put 2x.
That'd be wrong.
I thought you were supposed. Like you said in the last problem, I thought you said you're supposed to put an x after the real answer. This is so confusing, Mr. O'Brien.
All you're looking for is the same slope. So you have to have the same X over here.
Okay, so
After that, it doesn't matter.
I put 1,000.
1,000?
Yeah.
Perfect.
Okay.
I put 10.
If it would ever say to graph it, that might be a headache.
That's okay.
Okay. B. Josh.
Oh, okay. I put 3.
Sure. Again, any number there but 2.
With -2.
Any number but 2. Any number but 2. Again, all you're looking at is a slope. I'd have a positive 1x over here. Once I put the negative in there, I'd have a positive x. Parallel. Next one's a little trickier. Remember, this side is 3x minus 2. So this side, I need the same slope. So I can't put a 4x in there. That would change the slope. So how could I possibly change this back number but still be parallel?
-3x.
No, then it wouldn't be parallel.
Just scribble it out by another number.
10.
45.
Okay, so what's the slope have to be?
We got a 3x.
3x. Now how could I possibly change this back number?
Change it.
Get some light.
You add 2.
Put
Sure.
some white out.
So I would have to change it to 3x plus 2, or 3x plus 1, or 3x minus 4.
Whoa, that's so
Okay, I knew it had to be a 3x. But you had to add something to change that back number to make it not the same. All right, summary, bottom page 51 shows you kind of true statement, false statement. Should be pretty easy. Let's talk about the homework, starting on page 53. Number 1, 5 answers needed for number 1. Are they always true or are they never true? Always true means they're the exact same line. Never true would mean they're parallel. Never cross. So if you want to just put an A by the always true and by never, I'm good with that. A through E. Question number 2. Maya has a statement there. It says, do you agree, yes or no? Yes or no, and why, please, for number 2. Question number 3. Make it true for all values. Remember that means it needs to be the same on both sides. No values. That means they have the same slope, but different y-intercept. Do we need to simplify this, or can you do that? All right. Back page. Question number 4. Elena has a little thought there, so she can figure something out in her head. It says, how can she tell and explain why? Number 5. We have an equation. Elena solves it one way, does the first step. You want to figure out what did she do? What did Elena do to go from the original to her step? Same thing for Lynn. What did Lynn do?
Did things.
Okay, just describe the change. You don't even have to solve that. Just describe what they did. Question number 6, solving. That's what we did today. Give you a little note of which ones do not come out perfect. A and C are fractions today. So I'll put a little F by those. Those 2 are fractions. Middle one comes out nicely.
What have you done?
Final one, question number 7. Gives you a point and gives you the slope. Find 2 more points on the line. So if it was me, I'd probably graph it. Find 2 more points on the line, then write an equation. The graph should help you with that. Y equals something X, y-intercept. And actually the X you could fill out because you know the slope. Tells you in the problem. So this number you know. This one you're probably going to have to look at the graph. All right, so that is it.